Hi, welcome you all to Rapid Recall series, and this is actually the first video of Rapid Recall series I'm planning to do. Here onwards, I'll continue to upload videos on Rapid Recall series, considering the most important parts in our syllabus, and to give you a quick recall, a rapid recall within 10 minutes or less than that. So today we'll be quickly going through the linear motion, and here I'll be discussing everything you need to know about linear motion graphs, linear motion equations, linear motion graphs, and to sum up everything, at last I'll do a example question as well. What a linear motion is: if an object undergoes in a straight line or a linear path, that is called a linear motion. Simple as that. And this is actually the simplest type of motion we have in our syllabus, right? Okay. For that, we have 4 linear motion equations. So first, let's see what linear motion equations are with their parameters, right? Here you can see the linear motion equations we have. We have 4 linear motion equations altogether. V equals u plus ad, s equals ud plus half ad squared, v squared equals u squared plus 2as, and s equals v plus u over 2 into t, right? And their variables are, or the parameters are such that u is initial velocity, v final velocity, a linear acceleration, s displacement is also the linear displacement, t is time, right? So once other variables are known, a variable can be determined using one of these equations or using more than one equations together, right? And most important things about these equations are, all these 4 equations are vector equations. Since they are vector equations, all rules regarding vectors are valid here, right? So what are the basic rules regarding vectors? Basic rules regarding vectors are, we can apply the equation only along a considered direction. When we consider a direction, the vectors which are to the same direction of consideration are considered as plus, and vectors which act to the opposite direction of consideration are considered as minus. And if we have inclined vectors to the considered direction, they should be dissolved into components. And if we have perpendicular vectors to the considered direction, they will be neglected. And another important thing when using these 4 equations are, if you have different accelerations in different sections of the motion, we have to use the equation section by section, because when the acceleration changes, only one acceleration term is here in these equations. So therefore, when acceleration changes, we can use it for a selected section, for a chosen section only. Okay. Then if we move on to linear motion graphs, there are 3 types of linear motion graphs, as displacement time, velocity time, and acceleration time. If I recall you, the basic things that we are dealing in a graph are basically gradient. Gradient is either tan theta is the angle measured with x-axis, or you can write gradient as delta y or delta x, right? And basically we will be looking at areas of graphs. If you need to get area of any graph, multiply y-axis with x-axis, right? The parameter in y-axis with the parameter on x-axis. First one, displacement time graphs. Displacement time st, and gradient of displacement time is delta y or delta x. Delta y is delta s, and delta x here is delta t. So therefore, delta s over delta t is a velocity. So therefore, first learning is gradient of displacement time graph gives you velocity, right? And the second one, velocity time graphs. Velocity time, if I check the gradient of a velocity time graph is delta v over delta t. It gives acceleration, linear acceleration. And if we check area of velocity time graph is velocity into time, velocity times time, that is a displacement. So therefore, there are 2 things which are given by a velocity time graph. First thing, gradient gives you acceleration, while area gives you the displacement, right? Area under the curve gives you displacement. Acceleration time, there is no definition for rate of change of acceleration, so therefore we don't need to look at the gradient here, because there is no term for rate of change of acceleration, right? That is called rate of change of acceleration. And area gives, this is the important thing, the area gives a times t, so area gives a velocity, right? Now, to sum up everything that I discussed in linear motion, from linear motion equations to linear motion parameters to linear motion graphs, we'll do an example question and see. Okay, now you can see the question I refer to in the screen. Okay, now first I have a sketch what is given in the question. See, the bus starts from rest at t equals 0, and it has an acceleration 5 ms - 2 for 6 seconds, and it continues, it gains a velocity v, and it continues its motion with that same velocity v for 10 seconds up to 16 seconds. Then brakes are applied at this point in order to stop the bus in 3 seconds. So when t equals 90, the bus should be stopped. The final velocity v dash here is 0, and since this is a deceleration, I mark that acceleration in the opposite direction. First question is, plot a VT graph for the entire motion of the bus. The first part is an acceleration. So acceleration, then from here to here it accelerates with 5 ms minus 2. Right? It accelerates and it gains the velocity v. And from here to here it continues the motion with that gain velocity. And from 16 to 19 brakes are applied. At 19 the bus stops. Right? So at 19 it comes to here, and from 19 to 24 it is at rest. Convert above graph to respective ST and AD graphs. And if you have to convert this VD to ST, gradient of ST gives velocity. Gradient of ST gives velocity. Now velocity is known. Knowing the velocity, now I am going to convert this to gradient. This velocity is positive. This velocity is positive, and the velocity increases. So therefore, positively increasing. Right? This velocity is positive, and the value is constant. So that is a positive constant gradient. And this velocity is still positive, but the value decreases. So that is positively decreasing. And here, gradient of this horizontal line is 0. Gradient of the horizontal line is 0. Right? Now, what happens for velocity happens for gradient. Right? So this is a positively increasing gradient. Positively increasing gradient, positive constant gradient, positively decreasing gradient, and 0. Zero gradient means that's a flat line again, horizontal line. And a zero gradient means that's a horizontal line again. Now if I convert this Vt to At, this is the relationship we have. Gradient of Vt is acceleration. Knowing the gradient of Vd, convert it to acceleration. Now check gradients of Vd. Gradient of Vd. This gradient is a positive constant gradient, and this is a zero gradient. And this is a negative constant gradient, and this is again a zero gradient. Right? So what happens with gradient of Vd will be the acceleration. Positive constant. So acceleration is positive and constant. If gradient of Vd is 0, acceleration is 0. If gradient of Vd is negative constant, acceleration is negative and constant. Acceleration is negative and constant. And if Vd is 0, again 0. Then connect these lines, then you will get the respective AD graph. Part 3. What's the maximum velocity gained by the bus? Right? If we need maximum velocity, we can go to VD graph here. Maximum velocity is V. Right? So to determine it, this value is given as 5 ms minus 2. This acceleration is 5 ms minus 2. So let's assume this as alpha. So this is part 3. I can write tan alpha as V over 6. But tan alpha is given as 5. So 5 equals V over 6. V equals 30 ms minus 1. V equals 30 ms minus 1. Part 4 is, what's the distance travelled with uniform velocity? Right? So I explained you, distance travelled is given by area under curve of a VD. Displacement is the area under curve. It can be written as V is known 30 times 10, 300 meters. Next is the value of deceleration the bus had. We can write tan beta. Tan beta equals V over 3. So A is 10 ms minus 2. What's the distance between points A and B? The total area under this curve, that is a trapezium. That's a trapezium. Right? This is 19. Thus, this side is 10 over 2 into perpendicular height 30. Simplify this, it gives 435 meters. Right? So first you have to know the equation of average speed. Average speed equation is total distance over total time. Now total distance is known from here. Total distance is known, that is 435 meters. 435 over total time. Total time is not 19 because the motion continues up to 24 seconds even if there is at rest from 19 to 24. So therefore total time considered here is total time consumed for the motion is 24 seconds. Simplify this, it gives 18.125. I hope you have recalled everything you have to know here in linear motion, about linear motion and linear motion graphs. Right? And I'm going to wrap up the video here. Let's meet with another video of rapid recall series again. Bye bye.